Hi, my name is Stephanie Conklin. I'm here to talk to you today about a lesson called Tricky Tangent Lines, which you can find in the geometry curriculum. I'm going to talk about the beginning of the lesson. We start the lesson off by first asking students to review how to find interior angles. So if we have a circle and we have two chords intersecting, how students could find arcs and angles based on that. And then another question which asks students to find an exterior angle given two secant lines that go through the circle and start at the same point. After going through those questions, teachers can ask students to start a pair share in class notes, and students are in this activity going to prove, if we're given a circle and we have two chords inside of it, the relationship that exists between the segments of those two intersecting chords. And I've provided a couple different options for teachers to do here depending on your level of students. I've provided in the student notes really specific scaffolded directions for students, which I don't think all teachers need to use, but I'd rather give that to teachers so they have that resource. And basically, I provided the picture, a given and a proof statement, and then I've also provided some steps for a plan. So if you have an honors class, you might want to decide, I'm not going to give the students a plan, I'm going to let them just go ahead and try to figure out this relationship. But if you are following the plan, I've given a step. The first step meaning we're going to connect and create two triangles within the circle. And then I've provided a follow-up question, and it's for students to start thinking about what relationship these triangles hold. And then we're going to follow this up with step 2 and 3, where we ask students to write ratios comparing the corresponding sides. So hopefully in step 1, students will be able to realize that we have similar triangles, and once we connect the two chords, and you'll see directions more specifically in the notes. And then we're going to ask teachers and students to write ratios comparing each side. And then using cross products, students should be able to manipulate the ratios that they've written so that it looks like the proof statement. And so really what we're doing in this example is, or in this proof, is we're showing that because we have similar triangles, we know that the chords, when intersected in a circle, create basically a relationship between each other. I think that's it.